Let me tell you why I chose this location as a starter. This green field, it's very relaxing, and I hope that you can hear a little bit the birds singing, but there's something I want to show you here. I give you a clue, it's not that high power transmission line, but I think that we need to take some time to be able to understand these different electrical parameters. We're talking about current, voltage, power, resistance, as if they were very tangible and familiar things to all of us, but actually these things that exist in the electrical phenomena, that might be a little bit tricky and difficult to grasp. So the way that we explain this is by using an analogy. There's a particular analogy that I have a love-hate relationship, because at school I felt that I was obliged to understand, or at least repeat, that electricity behaves as water. But through the years I also have been making amends with such a fairy tale about how the electrons jump, because after all, the electrons are also a fairy tale. We will talk about that a little farther along the course, but there's even a book called There Are No Electrons. And the author makes a point that inside of the cable there is a party, and the little green men that is inside of that party are trying to attract each other, and through that analogy he carries on along the book explaining all the electrical phenomena. So if there are no electrons, well, hell, let's use the water analogy. And for this reason, some of you might already figure out I came here because there is a river, and I think that one way that we can relate this to electrical charges is to remember that MIT professor that he's combing his hair, and the hair evidences this electrical charge. I don't do that because of obvious reasons, but you will use your imagination right now and concentrate and think there's no water there, there are electrical charges. Electrical charges get measured by a unit that is a big capital C of Coulomb. We could imagine that if it's dry, then there's no electrical charges circulating. But if there are some, I would rather measure how many electrical charges circulate in a period of time. So I look at it and see how many are they passing, and that will be so many coulombs in a second. So there's a unit for that, and it's going to be the unit of current, that is ampere. How many coulombs per second? So 1 amp is 1 coulomb in 1 second, and we can measure it here, there, downstream, and it's going to be the same, because at the same pressure the body of water will go deeper or wider, whatever, but will measure the same amount. And that's what happens with cables that are thicker and thinner, but the flow of the current is constant. And let's try to use this analogy also of water to think about how much pressure or how much voltage a circuit has. Let's imagine that this river is coming upstream, and there's a pipe coming from a tank. If that tank is 1 meter tall, I can go there and put my hand, and I will feel how the water is coming to the river. And if that pipe is 10 meters tall, I put my hand, and probably I will feel that it's hitting my hand. And if I put that pipe 1,000 meters high over the river I have here, when it comes down, it's going to be dangerous. If I put my finger, it will cut my finger. And that's what we already know from electricity, right? We go and we put our fingers into the audio jack, the USB. We don't mind, we mess around with those. But everybody knows that we rather don't put things inside of a wall outlet because the pressure there is very high. 120 volts, 220 volts. We'd rather be careful with those. This is how, in a pipe, the pressure can start giving us a sense of voltage. Tiny battery, we touch it. Yeah, it's not dangerous for your human body. If you go over 60 volts, then it becomes dangerous, slightly dangerous. But if you go to 220 volts, it's just lethal, right? You don't want to touch something that has 220 volts with your bare fingers. And I hope that the water analogy helps as a visualization. The river is current flowing, and we measure it in amps. The voltage is a pressure that our circuit has. Okay, we have some visitors. I think there's some ducks. Yeah, you see them. Okay, but anyways, so the duck has the opinion that the voltage is actually very high.